Good morning and welcome to the second lesson of 3 in Algebra for the Project Maths Leave Cert exam. My name is Rory and I'll be taking the lesson today. So check if your solutions are correct and then do this a couple of times and eventually you should be able to pick it up. So today we're going to focus mainly on algebra skills. There'll be more lessons on this topic later, such as problem solving and using graphs to show what the solutions mean and how are the solutions. Simultaneous equations. So there's different types of simultaneous equations with 2 unknowns, 3 unknowns, substitution, and we'll look at also solving quadratics. So we'll use the formula for so we'll solve quadratics graphically and using graphs, and it'll help us understand what it means. But the focus for today's lesson is and so the first topic, like I said, is going to be linear equations. So we're going to look at some questions on linear equations. And first question, so you can follow from your book. This is on page 29 of your active maths book. It's book 1, active maths 4. So it's on page 29. And the first question we look at is 11. So this is a fairly simple example, but I've picked it for a specific reason that I'll point out to you. So the question is going to be negative x. Oh, I'll do the other x. It's better in this software to see. Negative x minus 3 in brackets minus x plus 2 in brackets is equal to 2x minus 1. So we're going to solve for x. So the question is basically solve for x, find out what x is. So when it says, or you're asked to solve for x, we'll try and find x. So the first thing we'll do is we'll multiply -1 by x and -1 by -3. So -1 by x will give me negative x, and -1 by -3 will give me plus 3. So the main thing we notice as teachers when students are doing this question is they multiply the first term by -1 and they forget to multiply the second term. So be careful here that you multiply x by -1 and you also multiply -3 by -1. And same for the second part, -1 here, it's not written, but negative x minus x plus 2 in brackets means -1 times it, although we never write the 1. So when we multiply that, we're effectively multiplying by -1. So there you have negative x minus 2. And that's equal to, again, we'll multiply it out, 2x minus 2. So now we'll put the x terms together first of all. So you've got negative x, so that's going to give you, of course, negative 2x. And then we'll put the other one together, 3 and -2. Plus 3, negative 2 will give you plus 1. And that's equal to 2x take away 2. So now it depends how you're taught this or how your teacher shows you. Sometimes you're told to bring the negative 2 to the other side and it becomes positive, which is fine, of course. But really what's happening is you're adding 2x to both sides. So if you add 2x to both sides, what in fact will happen, you'll get the same answer, of course. But what will happen is negative 2x plus 2x, they'll become no x, it'll cancel out. And we'll be left with 1 is equal to 2x, and 2x is, of course, 4x. Take away 2. And again, I can add 2 to both sides. Later, we will just maybe do them a little bit quicker. We can say when I bring the negative 2 to the other side, it becomes plus 2. But this will give me 3 here. 3 is equal to 4x. So therefore, I divide both sides by 4. Divide that side by 4. And when I divide this side by 4, 4x divided by 4 will give me 1x, or just written as x. And that will give me 3 divided by 4. So my answer here will be 3 divided by 4. X is equal to 3 over 4. And what you'll find is if you want to check your answer on this one, you can. So you can take 3 over 4 and substitute it into your initial equation up here. And when you substitute it in, this side of the equation will equal to this side. So now, excuse me, the next example we will look at is number 12. So our question looks like this. We've got a quarter x minus 1 plus 2x divided by 3 is equal to 5 divided by 2. So what we'll see here is if we've got 3 numbers as fractions, 2, 3, and 4. And when you've got a situation like this, what you need to do is find the lowest common multiple between 2, 3, and 4. And one way to find the lowest common multiple is to start with the biggest number, which is 4, and write out the multiples of 4. 4, 8, 12, 16. And we know 2 will divide into all of these numbers because 2 is an even number. And then we'll look at 3. Does 3 divide into 4? It doesn't. Does 3 divide into 8? No, it doesn't. Let's look at 12. 2, 3, and 4, all 3 of them divide into 12. So we'll take 12 and we'll multiply the full line here by 12. I'll write it out for you. And then our fractions will cancel and it'll become quite easy to work out the question. So the main thing here is removing the fractions as a starting point. So once you've got 12 times 1 over 4, x minus 1, plus 12 times 2x over 3 is equal to 12 times 5 over 2. And again, as teachers, the main thing we notice here is with students is sometimes they forget to multiply each of the terms by 12. So make sure you multiply all the terms. If you have 3 different terms, multiply them all. If you have 4, multiply them all, etc. So now we'll see that these cancel. 4 divided by 4 is 1. 12 divided by 4 will give me 3. So that's going to give me 3 x minus 1 plus, and I can cancel again here, 3 divided by 3 is 1. 12 divided by 3 is 4. So 4 times 2 is 8x. And that's going to be equal to 2 divided by 2 is 1. 12 divided by 2 is 6, and 6 times 5 is 30. So now all I need to do is multiply this out. 3 times x will give me 3x minus 3 plus 8x is equal to 30. So now I can put the 8x and the 3x together. So I'll have 3x and 8x is 11x minus 3 is equal to 30. Now when I add 3 to both sides, I will end up with 11x minus 3 plus 3 is 0, and 30 plus 3 is 33. And now again, I will divide both sides by 11. 11x divided by 11 will be 1x, and we don't write the 1, we just write x. And that's equal to 33 divided by 11 will give me 3. And there we are. So again, you can check your answer here. If you take 3 and you substitute it into here, you'll see that all of this side here will equal to all of the right side. So all of the left-hand side will equal to the all of the right-hand side. So you could pause the recording and try and do that and see if you can get the right answer. So now we will do one more question on linear equations, which is number 13. So this question looks like this. Again, with a fraction, y plus 3 divided by 4 minus 1 over 3 multiplied by y minus 5 is equal to 2 and 3 over 8. Like in the last question, we're going to find our lowest common multiple. The first thing I'll do is I will write 2 3/8 as an improper fraction. So what I mean by improper is the number on the top is going to be bigger than the number on the bottom. So I will just write that here. 2 times 8 is 16. So you can find it like that. 2 times 8 is 16. 16 and 3 is 19. So we can write that as 19 over 8. So I'll just write it there. And now we're going to have 4, 3, and 8. There are 3 numbers. So we want to find the lowest common multiple. I'll write them in number order, 3, 4, and 8. So again, like the last time, I'll start with 8 because it's the highest number. And I will write the multiples of 8, 8, 16, 24, 32. And I'll see which number, the lowest one that all of these divide into. So 3 doesn't divide into 8, so we can't use it. 3 doesn't divide into 16, so we also can't use that. What about 24? 3 divides into 24. 4 divides into 24. And so does 8. So our lowest common multiple here is 24. So I'll multiply my full line by 24. This side, because I've already written the fraction, I'll just write it out here, multiplied by 24. Here I'm going to have 24 multiplied by y plus 3 divided by 4 minus 24 times 1 over 3 times y minus 5. So again, like in the last question, we'll cancel out. So 4 divided by 4 is 1, and 6 divided by, or 24 divided by 4 is 6. I'm giving you the answer as well. 3 divided by 3 is 1. 24 divided by 3 is 8. And 8 divided by 8 is 1. 24 divided by 8 is 3. So now we'll just multiply that directly. So 6 times y is 6y, plus 6 times 3 is 18, minus 8 times this. So I'm going to have 8 times y, so which is going to be minus or negative 8y. And negative times negative is plus, so that's going to give me plus 40. And 3 times 19 is 57. So one way to do that quickly would be to multiply 20 by 3, which is 60, and take away 3, because 19 is 1 less than 20, so we take it away 3 times. So now we will put the y's together, which is called collecting like terms. So 6y take away 8y is negative 2y. 18 and 40 is 58, and that's equal to 57. So now I can take 58 away from both sides, so I'll have negative 2y is equal to 57, take away 58 will be negative 1. And now I divide by negative 2 both sides. So negative 2 divided by negative 2 will give me 1. And negative 1 divided by 2 will give me 1 over 2, or a half. So when I divide negative by negative, it gives me a half, and 1 over 2. Or you could write it as 0.5. It's the same answer. Here are the 3 examples we'll do on linear equations. The next section we're going to look at is simultaneous equations. So let's give you a subheader. Simultaneous equations. So first question we're going to do, and this is on page 31 of your book. Page 31. So the first one is just to show you how to do it. It's fairly straightforward, so I'll give you some ideas of how we could do it. With the simultaneous equations, there isn't always one way to approach it. You could solve the value for x and then find y, or you could solve the value for y and then find x. So sometimes you will find you will solve it differently from the person next to you and both get the right answer. And here we're going to have x minus 4y negative 23. So what I find a good way to do is if you label them, that's equation 1, that's equation 2. And this will help later to track your work and see what you're doing. Particularly if you want to look back at what you've done, it's very helpful to label it. So now I want to eliminate x or y here. And we can see that if I multiplied all of the second line by negative 7, I would have negative 7x. So when I added the 2 lines together, 7x and negative 7x would cancel each other out, or they would come to 0. But I also see that I've got 23 here, and I want to multiply it by 7. Alternatively, I could just multiply the second line by negative 2, and then I would have plus 8y, and the y's will cancel out, and my numbers are smaller. So I'll go and do that for that reason. So I'll write what I'm going to do. Multiplied by negative 2. So the first line is going to stay the same. 7x minus 8y is equal to negative 1. Stays the same. And the second line, I'll multiply everything by negative 2. Negative 2x plus 8y. And that's equal to negative 2 times negative 23 will give me plus 46. And now I will just go and add these 2 lines together and we'll see what happens. First of all, I'll add 7x minus 2x, which will give me 5x. And when I look at the negative 8y plus 8y, that'll be 0y. So they'll somehow cancel each other out or become to 0y. And negative 1 plus 46 will give me 45. And now I can divide both sides by 5. X is equal to 9. So now that I've found x is equal to 9, the next step I need to do is to substitute x equals to 9 into one of the equations. So I'll substitute it into the second equation. Again, I think the numbers are easier. So I'll sub it into equation 2. So instead of x, I'll write 9. So 9 here instead of x, minus 4y is equal to negative 23. So now if I take 9 away from both sides, 9 take away 9 is 0, and negative 23 take away 9 is going to be negative 32. So now I can just divide everything by negative 4. Negative 4y divided by negative 4 will give me y, and negative divided by negative is positive, y is equal to 8. So now I've got a value of 9 and 8. So what's actually happening when you're doing this is your solution, and I'll show you this later, I'll do a lesson later on graphs. Your solution is actually a coordinate. 7x minus 8y is equal to negative 1, and x minus 4y is equal to negative 3. They both represent straight lines. So what you have found when you find the point x and y is a coordinate, and it's actually the point of intersection of two lines. So you've got two lines and they intersect somewhere. That point is 9, 8, the point of intersection. So now we will move on and do another one. So this is number 11. This looks harder, but it's not necessarily harder. It starts off like this: x minus 3 divided by 4 plus 5 minus y divided by 2 is equal to 1 over 4. This is my first equation. And my second equation is this one: 2x minus 1 divided by 3 minus y plus 3 divided by 2. And that's equal to minus 13 over 6. So that's my second equation. So what we've seen before is we look for the lowest common multiple between 2 and 4 here. So the lowest common multiple between 2 and 4 is going to be 4. So I'll multiply all of this line by 4. And the lowest common multiple on this one, this second line, between 2, 3, and 6 is 6. So I'm going to multiply these lines by 4 and 6 each. So I'll start with the first one. I'm going to have 4 times x minus 3 over 4 plus 5 times, whoops, that's not correct. And really I should do this in brackets so I can't make a mistake. It'll help me, save me from making a mistake. Plus 4 times 5 minus y divided by 2, and that's equal to 4 times. Don't forget to multiply the second part also. So a common mistake we see sometimes is one of the things has been forgotten. So multiply every single piece. So that's, again, I'll label it my first equation. And I know what I've done. I've multiplied it by 4. So the second one, we're going to multiply everything by 6. So we're going to have 6. It's better to do it in brackets. 2x minus 1 divided by 3 minus 6, again the brackets, y plus 3 divided by 2, and that's equal to 4. Oh, that's from the last question. That's going to be equal to 6 times negative 13 divided by 6. And that's my second question, multiplied everything by 6. So we'll see what happens here now is we'll have lots of cancelling, and we'll end up with two equations that look much nicer to solve. So 4 divided by 4 is 1. So this will be x minus 3. 2 divided by 2 is 1, and 4 divided by 2 is 2. I'll just multiply this out in one go. 2 times 5 is 10, plus 10. 2 times minus y is minus 2y, and that's equal to 4 divided by 4 is 1, and 4 divided by 4 is 1. So that's equal to 1. So that's still equation 1, so I know where I am. I keep the labels on it. And now we'll do this one. 3 divided by 3 is 1. 6 divided by 3 is 2. And when I multiply these out, I get 2 times 2x, which is 4x. 4x minus 2 times 1, which is 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So I've got minus here, so that's part of this. Negative 3. Negative 3 times y is negative 3y. And that's going to be minus 9 equals 2. The two 6's again will cancel out. Negative 13. And this is my second equation. So I'll simplify these here. I'll just put x's and y's on one side. X minus 2y is equal to negative 3 plus 10 is 7. And you've got 1 here. So 1 take away 7 will be negative 6. And here you have 4x. I'll write them underneath each other. 4x minus 3y is equal to, and we have negative 2, take away 9 is negative 11. When I bring it over to the other side, it becomes plus 11. So negative 13 plus 11 is negative 2. So now I've got two reasonably simple equations that I can solve. And again, this one and this one represent straight lines. And when I solve them, I find the point of intersection. If there's no point of intersection, it means that the lines are parallel. So I'll do this over here. So I'm going to have x minus 3y. Whoops, that's 2y. Let's check that. X minus 2y. X minus 2y is equal to negative 6. That was my first equation. When I simplified it, I multiplied across to get rid of the fractions or remove them. And the second equation is 4x minus 3y is equal to negative 2, my second one. And now I'll do what I did in the first example. I will multiply one of the lines. So if I look at it, I think I will multiply the first line by negative 4. And then when I add them together, the x's will disappear and I'll be able to solve for y. So if I multiply all of this line, I'm going to have negative 4x. Negative times negative 2 will be plus 8y is equal to 24. The second line I will leave as it is. 4x minus 3y is equal to negative 2. And now when I add the two lines together, negative 4x plus 4x will effectively cancel. 8y minus 3y will be 5y. That's equal to 24 take away 2 is 22. And y, it's not going to be an integer, so it's not going to be a full number. It's going to be 22 over 5. So that's my first value, 22 over 5. Now what I need to do is take this y is equal to 22 over 5 and substitute it into one of the equations, 1 or 2, and find a value for x. So I'll do that now. I will say take y and I'll substitute it into the first equation. So I'll substitute it into equation 1. And I find this is very easy if you have -4 here, for example, and 1 here. Later you can follow your work and it makes it much easier to see what you've done. So I'll say x minus 2 times y is going to be 22 over 5. 22 over 5 is equal to -6. So when I multiply that out, I'm going to have, that's going to be -44 over 5, which is equal to -6. And I can say -6 is equal to -30 over 5. Because if I multiply 6 by 5, I get 30. And then I know if I divide -30 by 5, I get -6. So what we have is -x minus 44 over 5 is equal to, instead of -6, I can write 30 over 5. And I'll write that because it's easier to do my calculation, as we'll see in the next line. X is equal to -30 x is equal to 14 over 5. 14 over 5. And there we solved it. If you wrote it as a coordinate, really, again, it represents 2 lines. The 2 equations represent 2 lines in their simplest form or in their more complicated form. And when you're solving for x and y, what you're finding is, where do they intersect? Where's the point of intersection? And this is the point of intersection. 14 over 5 and 22 over 5. You could also solve it as a decimal. That would be 2.8 and 4.4. So you could have, for example, 2.8 and 4.4. That's also fine. Both are correct. They're both equal to each other, and that's effectively your solution. That leads us to the next part, and the title of this part, or the subtitle, is 3. Simultaneous equations. Equations in 3 variables. We're going to have 3 variables this time. So this is something that looks harder. It can be slightly harder, but actually we'll just do what we're doing already. So from your book, this first example is from page 32, and we're going to do number 7. So usually if you have 3 variables, you're going to have 3 unknowns, and an unknown is essentially just a letter. So you'll have x, y, and z. You could have a, b, and c, but generally x, y, and z are used. So our first equation is x plus y is equal to z. I'll label them again because for this one particularly, it'll make it easier to follow. 2x plus 3y is equal to 2z, and that's my second equation. My third equation is going to be x plus 2y is equal to 10. So I've got 3 unknowns in 2 equations and 2 unknowns in 1. So this will work out, in fact, easier than if I had a z in the third equation. So my three equations. So first thing I'll do is I'll start with two equations. I've got x and y here. So if I take x and y here in equation 1 and 2, I will eliminate x or y. I'll first of all eliminate z. I'll show you. I'll just rewrite them. It'll make it easier. X plus y is equal to z. I'll take equation 1, and underneath it, I'll write equation 2. 2x plus 3y is equal to 2z. That's equation 2. What I'll do now is I'll eliminate z. So I'll do that by multiplying all of the first line by multiplied by negative 2. So I'm going to have negative 2x minus 2y is equal to negative 2z. And the second line, if I leave it alone, I will have 2x plus 3y is equal to 2z. And this works out very nicely. Coincidentally, x's will also cancel. Negative 2x plus 2x will give me no x. Minus 2y plus 3y will give me y. And negative 2z plus 2z is 0. So y is equal to 0. So from equation 3, if y is equal to 0, I can find out what x is. X plus 2 times y. And instead of writing y, I can just immediately write 0. So x plus 2 times 0 is equal to 10. So, and we know 2 times 0 is 0, so x is going to be equal to 10. So we found already y, and we found x. And from the first or the second equation, x plus, or the first one is easier, x plus y is equal to z. So I can just say the first equation, x plus y is equal to z. And I know that x is 10. 10 plus 0 is equal to z. So therefore, z is equal to 10. And I found all three. So there we go. That's how you find a simple version with two unknowns. This worked out easily because here at this part down here, x's and z's disappeared and we're left with y, so we could find it easily. So let's look at something that looks a little bit harder. So what we're going to look at here is question 11. And this looks like this. I'll give you three equations again. X plus y plus z is equal to 5. This is my first equation. And the second one is 2x minus y plus 3. That didn't really work out very well. 2x minus y plus 3z is equal to 3. That's my second equation. And let's say our third equation is going to be 3x plus 2y minus 5z is equal to 21. So we've got what we call three equations with three unknowns. And unknowns are basically letters that we don't know what they are. And we're going to find a value for x, y, and z like the last time. So the first thing I'll do is I'll take equation 1 and 2. So equation 1 is this one, x plus y plus z is equal to 5. That's equation 1. And equation 2, 2x minus y plus 3z is equal to 3. And now what I can do is I can just add these two lines together and you'll see that the y's disappear. So that will give me 3x, y minus y is no y. And here we'll have 4z, so 4z is equal to 5 and 3 is 8. And this is a new equation, so I could call it equation 4 maybe. And I'll use this later. So now I will take another two equations and I will eliminate y again, and I'll have two equations with just x and z. So if I take my first equation here, and if I multiply it by everything by -2, we'll see that I'll have -2x minus 2y minus 2z is equal to -10. And if I take the third equation and I just add them together, I'll just write the third equation, leave it as it is. I'm going to have 3x plus 2y, and you can see now that the y's will cancel out, minus 5z, that's equal to 21. Minus 2x plus 3x gives me x. The y's will cancel out or eliminate each other. That's going to give me -7z. And minus 10 plus 21 is going to give me 11. So I could call this equation equation 5. And I use the Roman numerals to distinguish it between all the other numbers. So that's equation 5. So now we're going to solve equation 4 and equation 5. In equation 4, I have got x and z only, and equation 5, I have x and z only. So it's like the previous question we've seen earlier. We can use that to eliminate. So if I leave 3x plus 4z equals to 8, I'll leave this equation on its own. That's the fourth one. And equation 5, if I multiply it by -3, I will have -3x plus 21z. And that's equal to, when I multiply 11 by -3, I get -33. So that's equation 5. And we'll write what we did. We multiplied it by -3. So now 3x minus 3x is no x. And 4z plus 21z will give me 25z. And that's equal to 8 minus 33 will be -25 minus 25. So now I divide everything by 25 and I get z is equal to -1. So z is equal to -1. And when I substitute that into equation 5, I can find my value for x. So I can say x minus 7 times -1 is equal to 11. So that means x plus 7 is equal to 11. I could take 7 from both sides, or I can see that 4 plus 7 is equal to 11. So x is equal to 4. So I've got my value for x, got my value for z here, and now I can find my value for y. X plus y plus z is equal to 5. So I can say x is 4 plus y plus z, which is -1, is equal to 5. 4 take away 1 is 3. 3 and 2 is equal to 5. So y must be equal to 2. So I'm just going to rub this out here to make some space. So the next part of the equation that we're going to see is this one. Next part of this question makes it an interesting question. the next part says hence solve this. And hence means after this or because of this or use this somehow to solve the next part. So what we've got is this a squared plus b plus c plus 1 is equal to 5. I'm going to have three equations. That's my first one. Then you've got 2a squared minus b plus 3c plus 1 is equal to 3. And you also have 3a squared plus 2b minus 5 c plus 1 is equal to 21. So we can see, hopefully, the relationship now. Instead of x, I've got a squared. So we'll check it. Here I should have 2a squared then. 2a squared, yes, on the second line. And on the third line, 3a squared. So I can say that x is equal to a squared. And instead of y, we've got b. So it's not the same all the way through. On the second line, I've got negative b. And the third line, I've got plus 2b. So we can say y is equal to b. And in the same way, we can say z is equal to c plus 1. So now what we can do is use these values. X is equal to a squared. Our value for x is 4. If x is equal to 4 and x is equal to a squared, that means 4 is equal to a squared. A is going to be equal to plus or minus 2. Y is equal to b, so y is 2, so therefore b is equal to 2. And z is equal to c plus 1, so z is minus 1. So minus 1 is equal to c plus 1. When I take 1 and I take it away from both sides, I end up with negative 2 is equal to c. So for this question, first of all, we solved it for x, y, and z. And then for the hence solve part, we have just used the fact that we have solved it and let x equal to a squared, y equal to b squared, and z equal to c plus 1. And then we can see that it solves quite easily. So that's simultaneous equations in 3 variables. They're a bit longer, and essentially you need to be more organized. So that's why I use this notation 1, 2, and 3. So if I look back over my work, I can see 1, 2, and 3. Here and here, I can see that I've used equation 1 and 2 to get equation 4. Here again, I can see that I've used equation 1 and 3 to get equation 5. I see what I've done. I've multiplied it by negative 2. And here I've left them alone. So I can trace my work much more easily by using this notation. So now, before we do more simultaneous equations, we'll do another little subheader, which will be 4. And this is going to be solving quadratic equations. I'm going to show you how to solve these with the formula. So the formula, I'll write it here. X is equal to minus b plus or minus the square root of b squared minus 4ac. That's all over 2a. And this is on page 20 of the booklet. of your formula booklet. So essentially what you want to be able to do is know where it is, know how to use it, and then you're fine. That's really what you're looking for. Where's the formula? Get used to using it, looking in your booklet, being able to use it, and then you're good. So the first question we're going to do is 9, part 5. And this question is going to be on page 38. So in your book, if you're looking at your book, you can look at page 38. So like I said earlier, there's problem-solving questions and there's graphing questions, but I'll leave them to a further point. This lesson is just focusing on your algebra skills. So just checking you can do all the algebra, working through it, doing some examples. So our question here is going to be, part 5 is 3x squared minus 2x minus 23 is equal to 0. So some students are really good at solving. You can use different methods. You can get the factors of that add up to that, or you can just start trying to factorize it like this and putting in values. You could have 3x times x and see what happens and try things out. Sometimes the easiest and most time efficient and less time consuming way is just go ahead and use the formula. So we've got 3 values here, a, b, and c. That's an a there. So the values come from the coefficients of x squared, x, and the constant. So in this question, once we know how to use it, it becomes very easy. A is equal to 3. B is equal to -2. So that negative comes with a 2. And C is equal to -23. So now I take these values and I can just substitute them into the equation. So I can say my value for x is equal to minus b. So again, I would always say to use brackets. So probably the most place or the biggest error I see where people use brackets is a mistake. Plus or minus the square root of b squared, again, -2 squared minus 4 times a, which is 3, times c, which is -23. That's all square root. And all of that is over 2a. So 2 times 3. So that's equal to, x is equal to, negative times negative is 4, or is plus, not 4, is going to be 2 plus or minus, and the plus or minus indicates I should get 2 answers unless all of this is equal to the same thing. 2 squared is 4. 4 times 3 is 12. 12 times 23 is 276 plus 276 square root, and that's over 6. So I can just put this into my calculator and I'll get an answer. X is equal to 2 plus the square root of 280 divided by 6 and 2 minus. So you're going to have 2 answers, 2 plus the square root of 4 plus 276, which is 280 over 6, and you're going to have x is equal to 2 minus, and that's how you work out your 2 answers. Square root of 280 divided by 6. So my answers will be x is equal to, the first answer will give me 3.1222. So 3 should be enough decimal places, and x is equal to, from my second answer here, I will get negative 2.456. So I'll get 2 answers, 1 and 2. That's how you use the formula. So now we'll look at two more questions. One, just two different types, less straightforward and what we would call maybe more interesting. So you need a little bit more skill to solve them. I'll show you how to approach it and how to solve it. Like I said earlier, if you're watching the recording, you can pause the recording and try these questions yourself and then just check your answers. It's one good way to do it. This would be question 11, VII, so part 7. The question is 1 over x plus 1 plus 1 over x minus 3 is equal to 2. And our question tells us that x is not equal to -1 and it's not equal to 3. Now, why is it not equal to these two? Well, if I substitute -1 into the first part, I'm going to have -1 plus 1, which will give me 0. And we can't divide by 0, so it's not possible to have 1 divided by 0 because it's undefined. And for the second part, 3 take away 3 is 0, so you also can't have 1 over 0. So you can't have any value for x probably, possibly, except these two. So these are the only two values you can't have. So first of all, I'll show you this. Imagine if you have something like this, a fraction, so like 1 over 2 plus 1 over 3. So how would you do that? So what you could do is you get a common denominator by multiplying 2 by 3. 2 multiplied by 3. And then you would say 3 times 1, which you multiply 3 by 1 plus 2 by 1. And then you have 3 plus 2. It ends up being 5 over 6. We're going to use this method to solve this equation. So we're going to get a common denominator. So we're going to have x plus 1 multiplied by x minus 3. This is like 2 multiplied by 3. And on the top line, we're going to have 1 multiplied by x minus 1. So we'll just leave it as x minus 3 plus 1 multiplied by x plus 3. And we'll just leave it, or x plus 1, I'm saying the wrong order. X plus 1, and that's equal to 2. So now I can cross multiply. The first line is going to give me x plus x. 2x, but I'll write it out the long way to make it obvious. X plus minus 3 plus x plus 1. And that's equal to 2 times this x plus 1 multiplied by x minus 3. So here I will have x, and x will give me 2x. Minus 3 plus 1 is minus 2. And that's going to be equal to 2 times all of this. I'll multiply everything out. X times x is x squared. X times minus 3 will give me minus 3x. 1 times x will give me x. 1 times negative 3 will give me negative 3. So if I tidy this up a bit, I could say 2x minus 2 is equal to 2 times. We could have divided here this by 2, 2x by 2, 2 by 2, and 1 by 2. That would also be fine. This is going to be x squared minus 2x minus 3. So I'll multiply it out this time. X squared minus 2 is equal to 2x squared minus 4x minus 6. So I'll bring everything to one side, and that will give me 0 here because I'll remove everything from that side. I'll have 2x squared and minus 4x minus 2x is going to give me minus 6x, and minus 6 plus 2 will give me minus 4. And now if we want at this point, we could divide across by 2. So we could divide everything by 2 to make our number simpler. 0 divided by 2 is 0, is equal to x squared minus 6 divided by 2 is 3 minus 2. So now this is not solvable without doing the quadratic formula. So what we will do from here, from this point, is we will solve this equation with the quadratic formula. So we will do it over here. Section this off. So we're going to use the quadratic formula over here. X is equal to minus b, so minus 3 plus or minus the square root of b squared, which is minus 3 squared, minus 4 times a is 1x squared times c, and all over a. So 2 times 1, which is 2. So x is equal to, minus times minus is plus 3 plus or minus, and this works out as the square root of 9. Negative 3 squared is 9, plus negative 4 times 1 times negative 2 is 8 over 2. I'll get two answers, and you can work this out. The first answer is going to be 3.5615, and the second answer is minus 0. When teachers say this is a nice question, we usually mean difficult, but I think this is a mixture of interesting and difficult. We'll go through it and see. So x squared, software sometimes is not as responsive as I'd like. X squared minus 12x plus d is than the other root. So what I haven't said yet is what a root is. A root is basically where the graph crosses the axis. So when we're solving these equations, we're finding the point where they cross the axis, and that's called the root. So one of the answers is 2 less than the other one. So let's look. Square root of b squared, so minus 12 squared is 144, minus 4 times a, which is 1, times d, which is just d, so minus 4d, So that's again 4 times a. So 4 times 1 is 4. 4ad is 4d, because a is 1, over 2a, which will be 2. So if I simplify this a little bit, I'm going to have 12 divided by 2 is 6. Again, this is a common point where mistakes are made, to divide one part here and not both parts. Both parts, of course, have to be divided. So that's 144 minus 4d. And that's all divided by 2, all this part. That's already divided. So this is going to give me my roots. So one root is 6 less than the other. So my answer is going to be 6 plus something and 6 minus something. Not minus 1, but minus something. So plus and minus. So let's see. What if I think about, what if I plus 3 and minus 3? If I plus 3 to 6, I get 9. And if I minus 3 from 6, I get 3. So that's not going to work. 9 and 3 won't be 2 apart. So let's go lower. What if I plus 2? That's not going to work. What if I plus 2 and minus 2? 6 plus 2 is 8. 6 minus 2 is 4. 8 and 4, one is not 2 less than the other. There's going to be 4 in the difference. But it's still smaller than 9 and 3, smaller than 6. So let's try 1. 6 plus 1 will give me 7. 6 minus 1 will give me 5. So now I can say one root 5 is definitely 2 less than the other root. So if I want to plus or minus 1, that means all of this will have to equal to 1. So essentially 6 plus or minus 144 minus 4d, the square root of that over 2 has to equal to 1. And if I cross multiply, I can say 144 minus 4d is equal to 2, because I'm going to multiply 1 by 2. So to find the square root of this, it must all equal to 2. So if all of that equals to 2, we know that the square root of 4 is equal to 2. All of this must equal to 4. And if I want all of that equal to 4, I would have to take away 140 to get 4. So that means I know that 4d is equal to 140. And from here I can find out that d is equal to 35. So this is a little bit harder. So I put it into the equation and I try and find out what value I have to add and subtract from 6. So what will I add and subtract from 6 so that one root is 2 less than the other root? And I find out that if I add 1 and subtract 1, I get roots which are 5 and 7, or 7 and 5. They're my roots. There's 2 difference. 5 is 2 less than 7. So all of this, which is 144 minus 4d, the square root of that divided by 2, all of that has to be equal to 1. If I cross multiply, then I get just the square root part has to equal to 2. So for that to be equal to 2, inside the square root must be equal to 4. And if that's equal to 4, I can find out that 4d is equal to 140, giving me d is equal to 35. So again, logic, you need to use logic and mixture of different skills here, and have to be able to see it. But if you practice enough different types of questions, eventually you get more lucky and you start to see the answer easier. So I'll do one more type of question, and this this session, I'll look at simultaneous equation. So I'll just give you the next section is section 5. Simultaneous equations. And we're going to have one linear and one non-linear equation. Let's see how this looks. So this example we're going to take for this one is page 41, number 10. So it'll look like this. My first equation is going to be x minus 2y is equal to 12. And linear, this is a linear equation, so we know that x minus 2y, or maybe you don't know, but that represents a straight line. So if you see something with x's and y's and no squares, it represents a straight line. And our second equation looks like this. X squared plus y squared minus 10x minus 4y plus 4 is equal to 0. That's our second equation. Now that's definitely not a straight line. So that's non-linear. So linear means line, really. This could represent a circle. So what we're doing still is finding the point of intersection. So we're going to solve for x and y. So when we're solving for x and y, we're going to find the point of intersection of, for example, a circle and a line. So you could have 2 points of intersection, or if that's a straight line, you could have 1 point, which would make it a tangent, or you could have no points. It doesn't intersect the circle at all. So what we're going to look at is trying to find a solution for this. Like I said before, later I'll show you graphically how to do these questions and how they work out graphically. For now, we're just focusing on our algebra skills. So first thing I will do is I'm going to use substitution for this method. So I'm going to rewrite this equation 1 as x is equal to 2y plus 12. I'm going to take that and I'm going to substitute it here every time I've got x. So I'm going to substitute it into equation 2. So equation 2, I'm going to substitute this value for x into equation 2. So I'll start and I'll put it in brackets. So I'm going to have 2y plus 12 instead of x, that's squared, plus y squared. I'll leave all the y's together, minus 10 times, and instead of x again, I will write 2y plus 12 minus 4y, leave the y's, plus 4 is equal to 0. So now I'll need to multiply this out. So 2y plus 12, I'll just write it here, maybe it's easier to see. 2y plus 12 squared is going to be times 2y plus 12. Anything squared is multiplied by itself. So first I'll multiply 2y by 2y, which will give me 4y squared. 4y squared. And then I'll multiply 2y by 12, which will give me 24y. And when I multiply this, I will get another 24y. So that will give me 48y. And when I multiply 12 by 12, I get 144. And y squared stays as it is. Now I'll multiply out by negative 10. So that'll give me negative 10 times 2 is negative 20y minus 120. And again, negative 4y plus 4, they stay the same, is equal to 0. So now I'll take all the y squareds first of all. So I've got 4 . and you think you might have made a mistake. So you've got 4y squared and y squared, which is going to be 5y squared. Now we'll do the y's. 48y, take away 20y, will give me 28, take away 4 is going to be 24. So you're going to have 24y. 144 take away 120 is going to be 24 plus 4 is going to be 28. It's equal to 0. So now we see we're left with an equation. How can we solve this? We'd have to use the quadratic formula. So now you can start to see why sections are built the way they are. If you don't know the quadratic formula, it'll be very hard to solve this equation. So I'll just write this out on the next page, and then we'll solve the quadratic formula with that. Let me just write it out again. We're going to have 5y squared plus 24y plus 28 is equal to 0. Remove this. So I can say y is equal to minus b. So it's going to be minus 24 plus or minus the square root of 24 squared minus 4 times a, which is 5, times c, which is 28, all over 2a, 2 times 5. When I work this out, I get minus 24 plus or minus. This will all work out to 16 over 10. So y is going to be equal to negative 2.8 and y is equal to negative 2. So now what I need to do is take my first equation, and if you remember back here, my first equation was this one, x minus 2y is equal to 12. X minus 2y is equal to 12. And the first thing I do is I say y is equal to negative 2.8 from here. And I'll substitute it in there to find x. X minus 2 times negative 2.8 is equal to 12. X plus 5.6 is equal to 12. And when I take it away, I get 12 take away 5.6 is going to be 6.4. So this is one substitution will give me this. So in a coordinate point, it would be the point of intersection would be 6.4, negative 2.8 as a coordinate. And the second point now, if I say y is equal to negative 2, again, sub it in, x minus 2 times negative 2 is equal to 12. That's going to give me 4. Take 4 from both sides, and I get 8. X is equal to 8. And my second point here is going to be 8 and negative 2. So I've got two different points, 8 and negative 2. And they would be effectively the point of intersection of a circle and a straight line graph. So we can see from this equation, that's a linear graph. X minus 2y is equal skills on another topic. So we've gone through all of that and focused on your algebra skills. Later, we will do another lesson. Like I said, in the live lesson, we will split this lesson because there's a lot of content here, and you want to make sure you get all your algebra skills correctly. So the next part we'll look at to watch it. You could watch it all the way through and then watch it a second time and pause it and try the questions yourself on a piece of paper and check if you got the answers correct. And if you're watching live, you could just listen back. And the next lesson will be on Sunday, 10 a.m. So I look forward to seeing you there. Okay, goodbye.